Hi everyone, my name is Nicholas, and in this three-part video, I'll show you how to analyze trusses, beams, um, and I'll also show you how to determine section properties. Um, I'll also show you, if we have time, how to determine deflections in photo frames. Okay, so basically, in this first exercise, a tutorial, I'm going to show you how to analyze trusses to determine stresses like bending, like shear forces and axial forces. Okay, so if you go to my first slide. So basically, I'll show you, the analysis and design of trusses, but basically we're going to focus on the analysis of trusses because the design will come later on. So in analysis, what we want to determine is we want to determine stresses. In this case, we're talking about axial stresses, which is the compressive and tensile stresses. And those are the stresses that we can use later on in design in your next, classes. So basically, to get started with Prokon software, you start Prokon like any other software. And let me share with you the Prokon screen so that you can follow what I'm doing. So basically, that's what you get when you start your Prokon software. So you'll see you got the home tab, the analysis tab, steel. The steel, concrete, those are design tabs. You don't need to go there now. What you want now at this stage is the analysis tab. Okay, so you click on the analysis and then click on the frame analysis tab. Okay, so when you click on the frame analysis tab, this is what you will see. And let me just share it with you. Click on the frame analysis once, and this is what you will see. Share this now. Frame analysis. Share. So this is what you see when you open the frame analysis tab. So the first action that you need to do when entering when analyzing trusses is to enter the node numbers and node coordinates. Okay, these node numbers is what you call joints in your analysis classes, truss analysis, theory of structures classes. So basically, our first aim is to determine, to assign a unique node number for each joint. If you look at our truss that we have here, let me share this with you now. Again, if you look at our truss, the truss that we're going to look at in this exercise, this is how it looks like. Okay, as you can see, you've got 12 nodes on this truss, or 12 joints, and the x dimension, from 1 to 12 is 3. So you go 3 all the way through, and then you've got, so you need to work out, this is an angle of 30 degrees. And so you basically need to work out the vertical dimensions, okay? For example, I'm gonna have to enter the coordinates of each and every one of these joints. But for joints like number 2, I don't have the y coordinates, so I need to work that out using this dimension, using the 3 and the angle 30. Okay, so if I go back to my Prokon, let me share that. I go back to my analysis tab, frame analysis, share that. Okay, there you go. So that's your frame analysis. So input nodes. So basically node number 1 is my origin. So that's 0, 0, as you can see. So I need to enter node number 2. So node number 2 will be 3. 1.732. Okay. So basically you need to calculate the vertical dimension of node number 2. So basically I've already done that to save time. So let me just post the results of my calculations. There you go. Yes, there you go. So you've got node number 2. As you can see, it's the x dimension is 3. The x dimension is I can orbit. Let me orbit for you so that you can see what I'm doing. Yeah. So basically for node number 2, the x dimension is 3, and the y dimension is 1.732. And for node number 3, you've got the x dimension is 6. X dimension is 6, and then the y dimension is 3.42. Okay, you can zoom extents. You can zoom all, you can zoom in. What else do you need to know about this? That's pretty much it. So you do the same for each and every one of those, every one of those of those joints. Okay. So our next step is to look at the beams. Okay. So now with beams, what we want to do is to define the beam elements. Okay. So we define beam elements using the node numbers that we entered previously. Okay. I'll just delete this just to show you, how this works. Because I've already done it, just for the sake of, having a short video. But I'll just delete the internal members, just to show you how I did this. So basically, if you go back to our truss, if I share our truss again, where's our truss? There you go. So this is the truss we're working on. So you'll see that this guy says, use the frame analysis module in Prokon to determine the magnitude and nature of the forces, the members of the truss shown. Okay. So and then it goes on to say that the top chord of the truss is made up of 100 by 100 by 8 angle sections. Okay, that's the top chord. That's the bottom chord. Bottom chord is made up of the same material, and same angle size. The internal members are made up of 80 by 80 by L, angle sections. So when I go back to my frame analysis tab, I'm going to share that. Share the frame analysis tab. Okay, there you go. Okay, I hope you can see this. So basically what this guy is saying is that the top chords, so you need to use your node numbers to define the top chord. Okay, so you'll say node number 1, dash 2, 3, 4, 5, 6, 7, that's the top chord. And you give it a name. Now a name is just a name. It can be anything. It can be a letter, it can be a number, as long as it's unique for that particular member type. Okay, so top chords, I call them TC. You need to be consistent. Whenever you have top chords, you have TC. But the bottom chord is defined by nodes 1, 12, 11, 10, like that up until 7. That's the bottom chord. I call it the bottom chord. So let me define the internal members. So the internal members, you've got, node number 2 to 12, as you can see, to 3 to 11 to 4 to 10. Okay, then you enter or you click, or rather you click in that box. As you can see, that's your internal members. So you need to give them a name, okay? So I call them IN. You can type it in, IN, just type IN. The reason why it pops up now is because I've typed it in already. So then I need to define these other internal members. So I've got member 10. Sorry, let me see, how does it look like? No, it's 4 to 9, 4 to 9 to 5 to 8 to 6. Okay, there you go. So as you can see, Prokon, Prokon assigns a unique color for each, for each section type. Okay, so the internals are green, and the top chords are gray. Now, in some cases, you can, define releases. Basically, you can, in trusses. Normally, if you look at your theory class, in trusses, you normally have you normally make the assumption that all these joints are pin jointed, members. All these members are pin jointed, meaning there's no transfer of moment at those joints. So if you want to do that, you can assign releases, at each node by assigning P for pin. Let me do that for the first beam, which is the top chord, and then I can also decide. So now basically this is the release for the first node. If I have a beam 1 to 2, that would be the release on node number 1. Okay, and then this would be the release on node number 2. Okay, but now that I've defined a beam, one long beam, then it's going to do something like that. What I want to say is that in this particular class, this is just basically a demonstration of the moments in this truss are going to be very little. So whether you pin these, joints, these end members of these elements, these beam elements, you'll still get very small moments, But I just wanted to point that out, that you can pin those members, end members, so that you have absolutely zero moments in those trusses. in those truss members when you I mean, sorry, zero moments and only axial forces, which is compression and tension. But it's something that is not so necessary because the moments will be very little anyway. Okay, so I can let me just leave that out for now. It's just you can something that you can do. It's up to you. For this is just a beginner's course, and I'm not so particular about those details. So now the next thing you go to is, as you see in your beam, in your notes, it's a beam sections. Okay, so now we need to define beam sections. So in beam sections, what we want to define is we've assigned node numbers for the top codes, for the bottom codes, and the internal members. Now what we want to do is we want to assign the material type for each one of those members. Okay, this is the top code, but what material is it made of? And on our notes, we were told that the top code is made up of angle sections. The bottom code is also the same, angle section, and the internal members are made up of 80 by 80 by 8 angle sections. So how do you do that? I've already done this. So what you do is you click on the top, you click in this section name. You don't need to type anything. The section names will pop up. Remember, you typed, you defined these sections when you are entering beams. Okay, so when you come to the beam sections, the names will pop up, by themselves. Okay, so you just click in this drop down, click top code, click in this box. You need to click there, click in that box, and then you go to sections. Okay, when you go to sections, you look for your equal leg angles, because that there you go, equal leg angles, and then you look for 100 by 100 by 8, and then you'll have that. Okay. Just as an example, let me delete this just to show you how I did this. So I want to enter internal members. So I say I click in this drop down. There you go. IN for internal members. So they told us internal members are 80 by 80 by 8. I click in the box. You need to click in that box, and then you go sections, and you go equal leg angles. Obviously, it could be anything. This is just an example. It could be square hollow sections. It could be whatever it is. It could be concrete. It could be timber. It doesn't matter. Okay. So equal leg angles. Then you go 80 by 80 by 8. Okay. There we go. That's done. So next step is we're not dealing with shells, solids, or spring elements. We go to supports. Okay. And again, I've already done this, but let me just explain this a little bit before we continue. Okay. I'll just take you back to our truss just to see where we have supports, because you need to understand where's the truss. There you go. So basically, when you look at our truss here, you can see that we've got a support on node number 1 and a support on node number 7. Okay, we've got a pin support here, and we've got a roller support on node number 7. So when I go back to my Prokon and share my truss frame analysis, share. So on node number 1, we've got a pin support, and here we've got a roller support. Now this is how Prokon works. Prokon defines defines support fixities using the relevant letter. I mean the relevant direction. So basically, if you want to specify resistance to motion in the x direction, use the uppercase letter X. If you want to specify resistance to movement in the y direction, you use uppercase letter Y. If you want to specify resistance rotation, you use lowercase letters. Okay, so we've got a pin support on node number 1. So therefore, we shall specify resistance to movement in the x and y, which is uppercase X and Y. You can type that in, X and Y. Okay. On the number 7, we've got a roller support, which means resistance to movement in the Y. It can roll in the X, but there's a resistance to movement in the Y. Therefore, you enter Y, and which means that when you finish your analysis, you're going to get reactions in the Y here and reactions in the X and Y on node number 1. That's basically what it means. Obviously, there's more details as you go along. You learn this as you go along. That's the simplest, support fixity you can have. Then let's go to nodal loads. Again, I've entered this already, just simplify, to make this video short. If you look at our truss, let me share this truss again. Where's the truss? There you go. If you look at our truss, we've got a horizontal force, I mean a force, a perpendicular force of 20 kilonewtons on node number 2, 3, and then you've got 175 on 4, and this is 30 kilonewtons at 6. Okay, so if this is you can enter this at perpendicular, but you can also get the horizontal and vertical component, which is what I did, which is easier for normally for students. At the beginning, you can later on you can learn how to enter some of these forces, as they are. If I take you back to my truss, if you get the horizontal component here will be 10, and the vertical component will be 17.32 facing downwards. You can check that in your at home. Then I go back to analysis, share, frame analysis. As you can see, now the most important thing here is to choose a load case. Okay, now a load case means that you want to group all the loading that is given on your truss into one group, which is a load case. Normally in industry, you have different types of load cases. You've got wind loads, you've got dead loads, you've got live loads. Okay, but in this case, this is just a school example. We're not interested in the specifics of which load case you're using. Okay, so that's why the load case here is just basically just to group these loads together. So that software can analyze. The software can analyze them. All as a group. Okay, so I can write anything for the load case. Most important thing is do not write more than one load case, because you want all your loads to be to belong to that one load case. Okay, so you can write whatever you want. You can say load case DL, load case D. It doesn't matter, to be honest. It's just a load case. Okay, and as you can see, node number 2, I've got a 20 kilonewton perpendicular force, which I've resolved. To have minus 10. To have 10 and minus 17. I can use my cursor, my mouse to zoom, or I can use these zoom extents, zoom window. If you want to zoom a particular window, zoom all. You can orbit. You can use your mouse, like I said, to zoom your truss. Okay, so basically you do the same for all the other loadings. So node number, specify the node number, the direction of the force. This is in the y direction. Obviously it's negative because it's facing downwards. So that's your nodal load input. Okay. Next time, next lesson, we shall look at beams, and therefore you'll have beam loads. But in this example, there's no beam loads. It's a truss. So that's pretty much it with the input. The other thing you need to watch out. So basically, after that, that's all the input. So now let's go to the analysis tab. We want to analyze our truss. We say start analysis. Prokon says there's an error. So whenever there's errors, obviously you can't continue analysis. You need to say no. Prokon will send you where the errors are. Okay. Obviously there you go with your error. Click on the error. Self-weight not added. Okay, this is important. So what this means is that we need to specify whether we want to include the self-weight of these members. Remember, we added the top codes as an angle section of a certain size, same as the internal. Same as the bottom code, and we also had a different section size for the internal members. So what Prokon wants us to decide is whether we want to include the self-weight of these members in the analysis. Okay, so what we do, we come and say, look at this tab here, add on weight to load case. So this what this means is that you select whether to add on weight to load case D or not to add on weight. So basically, if I want to ignore self-weight, I'll say do not add on weight. That means I'm ignoring self-weight. Okay, and the results I get, I can quickly check with the hand calc because I'm ignoring the self-weight. Okay, so then I go to my start analysis. Starting to analyze. Okay, analysis completed. Maybe something that I didn't mention. Sometimes people get errors when they start analysis. Normally, that error is because you are working in full 3D, and yet this is a 2-dimension truss. So basically, don't forget to change your domain to 2-dimension. You go to settings, change your domain to XY plane. Okay, obviously the analysis type is linear, and that's that's enough for this stage. You don't need to look at these other options. So let's go back to our output. Look at your outputs. That's a deflection. You can zoom this and look at the maximum deflection. Prokon will give you the maximum deflection and the nodes at which it occurs in the X and Y direction. You can move your cursor around to look at deflection at each node. Then you go to your beam forces. Sorry, you got your reactions. The reactions come first. There you go with your reactions, a bit slow. There is our reactions. Okay, you've got a reaction, obviously in the X and Y since this is the pin support, and you've got a reaction in the Y since it's a roller support. Okay, you need to scrutinize your results and see, if these results, make sense. You can check this with a hand calc. Remember, we are ignoring soft weight, so this you can easily check with a hand calc, confirm that these results are fine. As a matter of fact, what I advise people, students, is I always tell them to ignore soft weight, then analyze the truss, because they can check, these values with the hand calc, the internal members as well, and then after that, if the values are correct, then you go back and include your soft weight in your analysis. Okay, so that's the reaction. So then you're going to go beam forces. So you've got different force types. You've got axial forces, you've got moments, you've got shear forces. Like I said at the beginning, this is a truss, so we're interested in axial forces. Axial forces are forces that are, acting parallel to the member axis. That is what your compressive forces and tensile forces. Okay, so in Prokon, the way the software is programmed, the red is means it's compression, and the blue is tension. I know in most classes, negative means compression, but you can check this with a hand calc. In Prokon, this red means this is a compressive force and this is a tensile force. Okay, so basically you can reduce actually the magnification here to 0, so that this so that you can be able to read off these values. Let's wait for it to change the magnification. Okay, so I can read these values, or I can read, basically read off these values. That's 242, that's 231. So those are compressive forces. This is a tensile force. Now you need to watch out, there's a background color, which is green. That's the members, remember those were the internal members, okay? So you need to be careful. For example, I know this is, so basically this is a tensile, obviously this is the tie beam. So so that's a tensile force of 200, okay? But you can check that with the hand calc, okay? That's the beauty about it. You can check these things with hand calculations to confirm what the software gives you. So next time we'll look at, when we look at beams, we'll look at other force types like moments and shear forces, and we'll also look at, beam envelopes. The other thing I want to note out is that that was results without soft weight. So normally in your exams or tutorials, we normally want you to include soft weight in your analysis. Okay, so what do you do? Obviously, in real design in the world, you design, members with soft weight. The soft weight is normally, the biggest portion of the weight of structures. So I'll go back to my my analysis. Okay, settings. Sorry, input. Okay, now I want to include soft weight. I'll go back, input, general tab. I want to include soft weight. So add on weight to load case D. This means that Prokon, in addition to the loadings that are in group D, that are in load case D, which is the loading that we entered, the soft weight is going to be added to that, to those loads. So basically the soft weight of these members is part of load case D. Okay, so which means you're including the soft weight of the members in your analysis. So I go back to my analysis and start analysis again. Okay, it's low. There you go with the deflections again. When we start doing portal frames, things like portal frames, we will be interested in the deflections. Okay, now we're not so interested in deflection, because this is the beginners exercise, but at some stage we shall be interested in deflections and and how much they are, in which direction, and things like that. Okay, you got your output of beam forces, basically the same drill. You can look at your reactions, this time including soft weight. Obviously you expect them to be bigger, yeah, okay, so you see this was 115 before, now it's 119. This stays 20. You should know why. It's a horizontal force. The soft weight does not act in that direction. So therefore the 20 stays as it is. This is a roller, this goes up. Force type, I expect the member forces, the compressive and tensile forces to go up, obviously, because you're including the soft weight. Okay, so force type, you go to axial forces, that's what we're interested in. That's the compression and tension. There you go. And yes, I remember this was, if I look at this member 1 to 2, I can zoom window. This is 238 now, 226. But this is including soft weight. So basically, I normally ask people to draw up tables, defining, the member, the beam type, the beam element, which is member 1 to 2. The force is 238 kilonewtons, and it's a compressive force because it's red. You can check, you can check the nomenclature. I mean, you can check the software's, uh, uh, the software, by using hand calculations, just to confirm whether this is, the red means compression and the blue means tension. And preferably do that without including soft weight, because the calculation, including soft weight would be tedious. So basically, that's pretty much it for the trusses for the first lesson. In the next video, I'll explain how to do the analysis of beams uh, using Prokon, and we'll take it from there. Thank you so much for watching this video, and I'll see you in the next video. I'll end this now.